f dash x plus next term will be HQ upon factorial 3 into f, this is double dash, I'm sorry, f double dash x, this is f triple dash x plus and so on. So n times, it may be number of times, because this is by only the first two terms are cancelled out, because these two first terms, this of b1d, these two values are cancelled out from this one. So this, the h square upon factorial to f double dash x onwards functions are being taken. Now, right hand side sign, the sign of right hand side, positive or negative, will depend upon if f double dash x is positive, greater than 0, positive, then positive, then the sign of right hand side of this equation, this is, let me take second equation, of right hand side of equation second will be positive. Will be positive, then the sign of right hand side of equation second will be positive if f dash x is not equal to 0 and is positive, because h is small, as h is small, positive or negative, positive or negative, positive or negative, h may be positive or negative, because it is whole square even number, so it will be positive always. So the sign of this whole factor, because the other terms are smaller than the first term, so total sign of this f double x will change that sign. So it will be positive or negative, will depend upon this value. Okay, so as h is small and positive, small and positive, or positive or negative, so it will depend upon the sign of this, the right hand side. So it means convexity will be there. In this case, this is convex curve, so it is positive value. So right hand side is positive, then convex curve will be there. So convexity, point of inflection will be on a convex curve. The point of inflection will be on a concave curve, then it must be negative. What is the second position here? And if second position here, if f double dash x equal to 0 and f triple dash x is not 0, and f triple dash x is not equal to 0, then the sign of right hand side will depend upon the sign of f triple dash x. Okay, now in this case HQ will also change the sign, and HQ will also be positive or negative. If it is positive, then it will be positive because it's HQ here. Okay, odd number, so it will depend. If it is negative, then it will be negative. Positive or negative, it will be positive or negative. Positive or negative, it will change the sign. It will not remain always positive. It will be positive or negative. Positive or negative, as HQ is an odd function. Okay, so it will depend upon the power of h, which is HQ here, odd number. So it will change the sign. So the sign of that will change. Let me now take what is the possibility then. How to test the convexity and concavity we have discussed about. And what is the point of inflection? Test of point of inflection. How do we find out that? Test of the point of inflection. Test of point of inflection. point of inflection. Test of point of inflection. If f double dash x equal to 0, as I've just told you, is 0, and f triple dash x is not equal to 0, is not equal to 0, or let me write here, is not equal to 0, then okay, then what we have to test here, if f double dash x, or let me take here d square y upon dx square, we have to find out second derivative, is not equal to 0, or first is equal to 0, let me take, is equal to 0, is equal to 0. First we have to put here to find out the is 0, because it will depend upon positive or negative. And y into, if I multiply by y, the y coordinate, d square y upon dx square is positive or negative, then the point of inflection, inflection will be on a convex curve, will be on a convex or concave curve. If it is positive convex curve, point of inflection will lie on a convex curve, and if it is concave curve, if it is negative, I mean positive, if y is positive, okay, this is also positive, then d square y upon dx is positive undoubtedly. So multiplying this is the whole square. So multiplying this y by this will be positive, because y is positive above the axis of x. Above the axis of x, y is positive always. Okay, but below, if this a point is lying below the axis of x, then y is negative, because y coordinate is negative. Then this value, if we multiply, and this value d square y upon dx square will also be negative. Multiplication of these two will be positive. Again, the same situation, that even if the point A is lying, the tangent point is lying below x-axis or above y-axis, if this is positive, multiplication of y into d square y upon dx square is positive, then convex curve will be there, or the point of inflection will lie on a convex curve. And if it is negative, because if it is negative, then below line, below this, it will be negative, it will be positive. Okay, even both are negative. Positivity again is showing that it's a convex curve. It's convex curve. And if it is negative, negative means if this value comes out to be positive and this is negative always, this multiplication will be negative then. Okay, so this is how the points of inflection we have to find out. So we put d square y upon dx square equal to 0. From that we find out the points. If those points are satisfying the given equation, that means the points are lying on the given curve. And those points are points of inflection. Okay, so points of inflection, the coordinates of the points of inflection we have to find out. For that we have to put d square y upon dx square equal to 0. Okay, because in that situation, d square y upon dx square will give us the solution. Solving that then equation, we will find out the coordinates of x and y, and those points will give us points of inflection. The points of inflection we have just calculated. That point of inflection is the difference is positive or negative. If it is positive, convex curve will be there. Point of inflection will lie on a convex curve. If it is negative, then it will lie on a concave curve. Okay, so this is what the process is. Now, before taking these questions, let me discuss about now some summary of this. Okay, so I have just discussed about that what is convex curve, what is concave curve, point of inflection is what, and how the concavity and convexity of the curves is discussed about. What the convexity or concavity of the curve. Okay, and point, where is point of inflection line? Let me change the marker and duster as well. Okay. Now let me change the duster as well. So a test of convexity and concavity we have discussed about. Now, there are certain other points. What is the test for the point of inflection? We have discussed that if it is 0, then d square by what is the test of concavity and the point of inflection lying on a polar curve and parallel curve is also to be discussed. So let me talk about the condition for that. Now, point of inflection, test for point of inflection, which we were discussing about. Test for point of inflection. What we do? Okay, for this, d square pi upon dx square must be equal to 0, and d cube pi upon dx cube is not equal to 0. If we have proved this, that d square pi upon dx square equal to 0, we will substitute from this whatever points are coming out, then we will substitute that in ds cube or d cube pi upon dx cube. If it is not equal to 0, it exists. That means point of inflection will lie. Okay, on a this is on Cartesian coordinates here. Now, in case of test of point of inflection on a polar curve, for that, now test of inflection, test of point of inflection on a polar curve, inflection on a polar curve. What is the test for that? Now, in case of a polar curve, let me write here. In case of a polar curve, at the point of inflection, the radius of curvature, is infinite. The radius of curvature is infinite. And how do we give this radius of curvature? The radius of curvature is given by rho equal to, within bracket, r square plus dr upon d theta whole square whole 3 by 2 divided by, this is r square plus dr upon d theta, r into dr upon d theta, r square dr upon d theta whole square minus sin r into d square r upon d theta square. Okay, this is known as radius of curvature, or known as rho, is represented by rho. This is radius of curvature in case of polar curve. In case of a polar curve, at the point of inflection, the radius of curvature is infinite. This is infinite. It means the denominator must be 0. This is something upon 0 means infinite. Your rho is infinite. This is equal to infinity. That means this is 1 upon 0. It means this denominator must be 0. So denominator, if it's 0, then it must be polar in case of polar coordinates. So this must be 0. Okay, this is the condition for polarity of a curve. At a polar coordinates, in case of polar coordinates, okay, in case of polar coordinates, we have to have, this is okay, this is twice here, I'm sorry, this is 2 times 2 dr upon d theta, and this is power 3 by 2, no problem, minus r d g square r upon d theta square. This is in case of polar coordinates. In case of polar coordinates, radius of curvature is infinite. Radius of curvature is infinite, we are given. Okay, so in that situation, we will have this position. So dr upon d theta is equal to this. Okay, all right, and just searching for the duster here. Okay, so this is infinity. That means the denominator must be 0. All r square plus twice dr d theta whole square minus r into d square r upon d theta square must be 0. Why? Because infinity means 1.0 something upon 0. Denominator must be 0 here. This is the condition for polar coordinates. In case of polar curve, in case of polar curve, curve is a polar, then polarity, in case of polar curve, this condition must be satisfied. For that, we will substitute r square plus 2 into dr upon d theta whole square minus r into d square r upon d theta square equal to 0. So the denominator must be 0. Only then the radius of curvature is 0. Now, in case of pedal equation, what is the condition for pedal equation? Let me talk about that also. In case of pedal curve, okay, in case of pedal curve, what is the situation? In case of the pedal curve, we must have r into dr upon d must be 0. But there also the radius of curvature is infinite. So in case of polar pedal equation, in case of pedal curve, in case of pedal curve, r into dr upon dp must be 0. Okay, or r upon, this is dp upon dr, we can say equal to 0. This is the condition for, okay, pedal equation. dp upon dr is differentiation of the pedal equation with respect to r here, the radius. So this is the condition for pedal equations. So in case of pedal equations, we must have r dr upon dp equal to 0. Okay, so that is how the pedal equations are given. The point of inflection for pedal curves, we have in pedal curves, we have the radius of curvature rho is given by this here, rho into r dr upon dp. So this is the rho radius of curvature here. So r is given by r upon, this is r here, or r upon dp upon dr equal to 0. So in this case, the radius of the curvature is 0. Okay, in case of pedal equation, this is the condition for pedal equation. So these are three cases. First, Cartesian coordinates we discussed about, then polar coordinates we discussed, polar curves we discussed about, Cartesian curve we discussed about, and now we have discussed about pedal curves. So pedal curves, so these are the three conditions, and we have discussed about what is the concavity and convexity of the curves. Okay, now let me discuss about how to find out, what the process of finding out the point of inflection. Okay, so for that, double derivative must be equal to 0 and triple derivative is not equal to 0. But from that equation, from that Taylor's equation we discussed about, the triple equation must be h square upon factorial 2 into f double dash x. If it's 0 and triple dash is not 0, then the sign of that will depend upon whether it's positive or negative, because if it is positive, the value is positive of okay, d square r upon, d square y upon d x square, or double derivative into y. Y is positive in case the curve is on above the axis of x. If it is positive, in below also, if it is positive, then also the curve will be convex curve, or the point of inflection will lie on a convex curve. If it is on concave curve, then it must be negative. Okay, so that is another point we discuss about. Now let me take the questions here. What are the questions? So let me clear this. Okay, so first question number 1, let me discuss about now. The point 1 here, let me now talk about that. So pedal curves we discussed something about, polar curves we discussed about the condition of that for the polar curves. Okay, now question number 1, what does it say? Now it says that so that the curve this y equal to 1 minus x square, x upon 1 plus x square has 3 points of inflection which lie in a straight line. Okay, if they are lying in a straight line, then whatever the equation we will find out first 3 points, then passing through 2 points we will find out the straight line. If that straight line is satisfied by the third point, then we will say that three points are lying on a straight line. So first position here is that we have to find out the 3 points lying on a curve this. Show that the curve this has 3 points of inflection. So for 3 points of inflection we find out by double derivative equal to 0. We will solve then the equations, and whatever the points comes out, coordinates of x and y comes out, then those points will be the points of inflection. But if those points of inflection and through maybe there are 4 or 5 points or 3 points here, 3 points are there. So we will just find out that a straight line passing through 2 points, we will calculate that what the equation of a straight line passing through 2 points is given by y minus y1 equal to y2 minus y1 upon x2 minus x1 into x minus x1. So this is the equation from coordinate geometry we know about. That equation we will find out. And after solving this equation from 2 points, passing through 2 points, then the third point, if it is satisfying this equation, then we will say that these 3 points are lying on a straight line. This is the process of this question. What we have to do, first we have to find out that what is the curve given here, then derivative. So here question number 1 says the curve, let me take this curve, here curve is y equal to 1 minus x divided by 1 plus x square. Okay, so solution. So first of all, for point of inflection, we have to find out. Let me write here, for point of inflection, what we find out. For point of inflection, we equate d square by upon dx square means double derivative equal to 0. Then we will say that d square dq by upon dxq is not equal to 0. So we will say that yes, there are points of inflection here. Okay, and d square by upon dx square is equal to 0. We will find out this, and then those 3 points are to be calculated. So let me first find out what is double derivative of this. So differentiating the given equation. This is equation number 1 we are given. So differentiating first, let me write here, with respect to x. Okay. Progressively with respect to x, we get dy dx is equal to differentiating the right hand side by quotient rule. What the quotient rule? Denominator 1 plus x square as it is, ddx of numerator, which is 1 minus x, minus sign in between. Now 1 minus x as it is, ddx of denominator, this is this much, divided by whole square of 1 plus x square whole square. Okay. Now let me solve it. So this is minus 1 here. 1 minus x is differentiated as minus 1. So minus 1, if I multiply, this is 1 plus x square, minus sign, this is 1 minus x into twice x, this is 2 into x. Okay, divided by 1 plus x square whole square. Let me further solve it. It will give us minus 1 minus x square. From this is minus twice x plus minus plus here twice x square divided by 1 plus x square whole square. What do we obtain here? This is 1 plus x square. Okay, so this is x square, twice x square minus x square is x square minus twice x minus 1 divided by 1 plus x square whole square. Okay, this is first derivative. Now let me find out its second derivative. So we have obtained this as the first derivative. Let me write it here. dy dx is finally obtained is this much x square minus, or we can write it as, this is x minus 2x minus 1 divided by, it was minus 1 here, okay, no problem, upon 1 plus x square whole square. Again differentiating d square by upon dx square is equal to, this is 1 plus x square whole square. Differentiation of this will be twice x minus 2. Differentiation minus now x square minus twice x minus 1 as it is. Differentiation of this will be 2 into 1 plus x square. X square is again differentiated, is twice x. It will be into 2x divided by 1 plus x square whole square, that means whole 4. It will be 4 times. Its power will be 4. Okay. So now let me further solve it and then equate to 0. So d square by upon dx square equal to 0 imply that this equal to 0, but this numerator will come out. This implies that 1 plus x square whole square into twice x minus 2 minus sign, this is twice 2 to the 4x into 1 plus x square into x square minus twice x minus 1 only equal to 0. So what is common we find here? We find here this 1 plus x square is common, and into 2 is also here. 2 can be taken common. This twice into 1 plus x square common. Here x minus 1, got 2 we have taken outside. So x minus 1 into 1 plus x square. This is 1 plus x square into 1 minus x from this first equation. We have obtained this 1 plus x square, 1 will left over. For 1 plus x square we have taken common. Okay, and then minus sign. But 2 I have taken common, so 2 is there. 2x will remain here. This is twice x. 1 plus x square we have taken outside, and this is x square minus twice x minus 1 equal to 0. So from this one, x equal to plus minus 1. X equal to plus 1 and minus 1. Sorry, this is not possible because here x is equal to plus minus I, which is not possible here. This solution, x square equal to minus 1, which is minus I minus, which is not possible because it's imaginary, non-real number. Only solving this equation will give us something. Let me solve that here. So what are the values of this equation? Let me first find out. Okay, solving this equation, it will give us, okay, so this is 1 minus x into this whole cube. So if I solve it, it will be, if I multiply by 1, it is 1 minus x, then by plus x square, this is x square minus x cube. And from these two, we will have minus twice x cube, and plus 4, 2 to the 4x square, and minus plus again plus 2x equal to 0. Okay, so further solving it, let me find out value then. So what is the value further? Here it is x cube, 3x cube, 4x square and x square, 5x square. So it is 5x square, this x and this x, and minus 3x cube, okay, and plus x, and this is plus 1 here, plus 1 only, and this plus 2x minus x is plus x. Okay, x square and minus 2x square is minus x square. Okay, I'm sorry, this is plus 3x square is 5x square. Okay, 5x square because x square is minus this minus 3x cube. Okay. Now, so this is a cubic equation equal to 0. If I write it again as minus 3x cube plus 5x square minus, plus x plus 1 equal to 0. If I substitute here x equal to minus 1 plus 1, sorry, if I put x equal to plus 1, not going to, or minus 1, it will become positive 1. So is it minus 1 minus x upon 1 plus x square? We'll check this question. So d square by upon dx square. Here the points of x comes out to be x equal to minus 1 or plus 1. Okay, so let me check whether I have committed a mistake or not. Because values of x are not coming out. Here, what are the values of x? Let me change the marker here. It's not working. Alright, so point of inflection. Here we have committed some mistake here. Let me further do it. Some mistake has happened. Let me check whether I have committed any error or something. Again, let me find out d by dx. Some mistake has happened. d by upon dx from this function, this is 1 minus x upon 1 plus x square. That's the right question. You can check the value here. The value here. 1 minus x upon 1 plus x square. Alright. Question is okay. Now let me check it. So, differentiation of this 1 plus x square as it is. Denominator as it is. Differentiation of numerator is minus 1. So it is minus 1. Minus sign. In between we put minus sign. This is 1 minus x as it is. Differentiation of now this is twice x divided by this is 1 plus x square whole square. Let me further solve it. This is minus 1 minus x square, and here it is minus twice x minus plus here plus 2x square upon 1 plus x square whole square.